All right, today we're doing something a little different. We are shrinking down, way, way down, to take this incredible journey into the microscopic world of the human eye. We're going on a tour of the stunningly complex architecture that, lets us see everything. And I mean really close. We're not talking about the blue or brown or green you see in the mirror. We're talking about the living, breathing machinery that's working nonstop just beneath the surface. Honestly, you're going to want to forget what you think you know. So we're going to hit three main spots on our tour: the cornea, the retina, and the lens. Think of this as getting an exclusive, behind-the-scenes look at some of the most sophisticated biological engineering on the entire planet. Our first stop is right at the very front of the eye, the cornea. Now, this isn't just some simple shield. It is the eye's main window to the world, and you would not believe how meticulously it's put together. Okay, so the cornea basically has two huge jobs. First, it has to be perfectly crystal clear. Second, it does almost all the heavy lifting when it comes to focusing light, about 2/3 of the eye's total refractive power. And the craziest part, it does all this without a single blood vessel, because of course, those would just get in the way of the view. The way the cornea is organized is just remarkable. It's built in 6 distinct layers. Right on top, you've got the epithelium. It's this self-healing shield that completely replaces itself every week or so. Insane, right? Right under that is Bowman's layer, which is tough and gives the cornea its shape, but it doesn't grow back if it's damaged. The main event, though, is the stroma. It makes up 90% of the cornea's thickness, and its collagen fibers are laid out in this perfect grid to keep things transparent. Then there's Dua's layer, which was only discovered recently. It's super thin but incredibly strong. And finally, way at the back, you have the endothelium. It's just a single layer of cells, but they act like these tiny, tireless pumps, constantly pushing fluid out to keep the whole thing from getting cloudy. So you might be wondering, why do all these layers matter? Well, it's this exact structure, this precise layering, that makes surgeries like LASIK even possible. Because surgeons understand each layer's job, they can go in and reshape the cornea with unbelievable accuracy to fix your vision. Okay, let's keep moving. We're heading to the very back of the eye now, to the retina. If you think of the cornea as the eye's main lens, then the retina is the film in the camera. It's the digital sensor. What the retina does is, frankly, nothing short of a miracle. It's this super specialized neural tissue, and it's designed for one thing and one thing only: phototransduction. That's the fancy word for the magic trick of turning actual particles of light, photons, into the electrical signals your brain can understand as sight. The cells doing all this work are the photoreceptors. And you've basically got two types. You've got your rods, which are the low-light specialists. They're why you can navigate a dim room. And then you have your cones. They're responsible for all that sharp, high-definition, full-color vision you use all day long. But here's the thing. The photoreceptors are just one piece of the puzzle. The retina isn't just one sheet of cells. It's a stack of 10 distinct layers. Each one has a specific job, from feeding the system, to processing information, to sending that final signal off to the brain. It is genuinely one of the most organized structures in the entire human body. And here's the real-world payoff. When your eye doctor uses one of those modern OCT scanners to look at your retina, they're not just seeing a flat surface. They're seeing a beautiful cross-section of all 10 of those layers. This lets them spot problems with incredible pinpoint accuracy. It's a game changer. All right, for our final stop, let's look at the eye's incredible dynamic autofocus system, the lens, and the powerhouse that controls it, the ciliary body. So the lens isn't just a static piece of glass. It is a living, growing thing. It's wrapped in a flexible little bag called the capsule, and it's just packed with these special transparent proteins called crystallins. And what's wild is that it never stops making new lens fibers your entire life, growing from the outside in. Now just stop and think about that for a second. Because the lens adds new layers on the outside. The very center of your lens, the part that's in your eye right now, is made of the exact same cells you were born with. It's like a tiny, perfect, living time capsule of your entire life. But, the lens can't do its job alone. It gets all its instructions from the ciliary body. This is a ring of muscle that does two absolutely critical things. It physically changes the shape of the lens so you can focus, and it also produces the fluid that nourishes the front of the eye. Let's break that down real quick. You have the ciliary muscle, that's the engine that flexes and pulls to change your focus. Then you have the ciliary processes. Think of them like tiny faucets that are always on, secreting that vital fluid. And then there's the pars plana, which is this unique area with no blood vessels, making it a perfect, safe entry point for surgeons. So when you put it all together, this whole system is constantly managing two things that are absolutely vital for your sight: the crystal clarity of your focus and the stable internal pressure that keeps the entire eyeball healthy and happy. So there you have it. From the cornea's multi-layered window, to the retina's 10-layer digital sensor, to the lens's living, breathing autofocus system, the eye is, without a doubt, an absolutely astonishing piece of microscopic engineering. Every single layer we've looked at today tells a story, not just about our vision, but about our overall health. Which really makes you wonder, as our technology gets better and we can see these structures in even more detail, what other secrets about our own bodies are just waiting there to be discovered? What else will we find inside the microscopic world of the eye?